Okay guys, in this video we're gonna be solving electrical circuits. So the first one that we're gonna solve is the experiment. So the grade 12 learners did some experiment and then they started with two potatoes. So they started with two potatoes connected in series. So it's more like it's your cells. So you're just gonna have to draw something like this. So this is how you can draw your electrical circuit. The two potatoes, and then they said there's a bulb, light bulb on that experiment. Then you can do this. So this represents your electrodes, so you can say it's electrodes. Okay, and then they are connected in series. They connected the voltmeter directly across the outer electrode and measured a potential difference of 1.6. So the outer electrode, they mean it's your EMF, it's your total voltage across that circuit. So it's your total voltage. So I'm gonna write EMF is equals to 1.6 volts. Okay, then they say they then connected a 1.5 pen light bulb between the electrodes. You see, between the electrodes. So we can just say, I'll just draw a light bulb there between the electrodes. So what I can do is, let me just do this to make it simple. I'll just draw it as a pen light bulb. I'll just draw a normal bulb between the electrodes. So I'll draw them like this. Then they said this light bulb between the two electrodes is 1.5 volts. And then the total across the two electrodes, the total EMF, that one. The total EMF is equals to 1.6 volts. And then they observed that the bulb did not glow. So the voltage was too small, that's why it didn't glow. When they measured the potential difference across the bulb, it was 0.02. So it's too small. 0.02 is too small, guys. It's too small, so the light won't glow. So this light requires 1.5 volts to switch on. Okay, so the V bulb is equals to 0.02 volts. So you see that's the volt drop. This is what the bulb is taking. So this is the voltage that is going through that light. Across that light there's a volt drop of 0.02. So meaning there's a V loss. There's a V loss because you've got the EMF and then you've got the V bulb. Remember, EMF is equals to I, so I'll say IR, the external resistance. So this one I can say it represents the V bulb. Remember, IR is equals to a V bulb. V bulb, EMF is the total voltage across that circuit or in that circuit. Then plus I and the small r, the internal resistance. You see? So this one represents the V loss. Okay, so we know that we have got 1.6 volts of EMF, then the V bulb is 0.02, then plus we don't know the V loss due to external resistance. So what you're gonna get there is the V loss. what you're gonna get there is the V loss. So the reason why this bulb didn't go on is because there was a V loss due to internal resistance. So the internal resistance took some voltage there. So you can just calculate this, then you'll get 1 point. So if you punch it on the calculator, so I'm just doing this just extra information. 0.02. Okay, so it's 1.6 minus 0.02. So that's your V loss, 1.58 volts. So I'm just doing it for interest sake. Okay, so they say, what is the EMF of the battery with two potato cells connected in series? So you've got two cells, two potato cells. So you see, this is cell number 1, cell number 2. So what is the total EMF? So I already told you that the total EMF, number A, the total EMF is equals to 1.6. That's the total EMF between the two cells. So it's 1.6 volt. Then B, give a reason why the potential difference across the bulb was only 0.02. I told you that there was a V loss due to internal resistance of the battery. So there was a voltage loss due to internal resistance of the battery. There was a loss there is internal resistance of battery. So there will be a volt drop, a V loss, due to internal resistance of the battery. I already explained that. That's why. So the light bulb required 1.5 volts to switch on. So anything less than that, less than 1.5 volt, it won't go on, it won't glow. So the only voltage that was going through that light, it was 0.02, right? Okay. And then C, they say the bulb has a resistance of 2. Okay, let's write it. You see on this circuit, this it acts like a resistor. So they say R bulb. You can name it R bulb. Resistor of the bulb is 2 ohms. So now look at that. In that circuit, you have got R bulb and V bulb. So you've got R bulb of 2 ohm and V bulb of 1.6. Sorry, not 1.6. The 1.6 is the EMF. Sorry, 0.02 volts. Then the question says, calculate the power dissipated by the bulb even though it is not visible. Okay, even though it doesn't glow. So P is equals to IV. You know power is equals to IV. So I told you that we're gonna use Ohm's law. V is equals to IR. So this is how you're gonna manipulate this thing. So this question. So remember, this is Ohm's law. This is Ohm's law. So you know that your question, in order for you to calculate power, you need a formula that has got R and V. So we don't need I. So let's get rid of this I from the standard equation of power. This is a standard equation of power. So I'm going to show you how to solve that formula. So I'm going to simplify the formula. So I need to take I out. So I'm going to the Ohm's law. So there's your Ohm's law. So I'll go to the Ohm's law and make I the subject of the formula because that's what I'm looking for on that V. P is equals to IV. So I'm going to make I the subject of the formula there, V over R. So where there is R, I'm going to put V over R. So P is equals to V over R, open bracket, then there's another V, the original V, this original V, that V. And then P will be equals to V squared over R. So that's how they do the formulas. So you've got V of 0.02 squared divided by R, which is 2 ohms. So your final answer will be, so you can do it on the calculator. Let's bring the calculator there. 0.02 squared divided by 2. Okay, so there is your power. So it's 2 times 10 to the power of 4. Then you can write it in watts. Remember, you should write it in watts. And that's it. That's how you answer that question.